Alright, so I've got solution A and I got solution B. Now what they are right now is very basic solutions. So if I take a capillary tube and I drop a little bit and I put it on a piece of pH paper, what I get is a green color for solution A, which indicates that it's mildly basic, and then definitely for, just going to drop that in there, solution B, I drop it in there, I get this deep blue, which indicates that it's super basic. So why don't I want to stick this tip in there directly? Well, it's hydrogen paper. It'll leach out, so it's better to use these capillary tubes. Now what I'm going to do is I'm going to add HCl until the pH reaches a maximum here. Let's see what it says. Maximum about 3 to 4. Honestly, it's okay if you go over. So if I take solution A and I add an ml of acid, what I see is that there's this kind of foggy precipitate that forms, but then it immediately disappears. What you're seeing right now is the reaction of bicarbonate with the acid, so I need to add more. While that reacts, I'm going to go ahead and add it to this solution here. You see there's no reaction here. This is sodium hydroxide with HCl. It doesn't produce really anything other than salt water. Let me add just a little bit more. So bicarbonate here is kind of a nice self-indicator in that it will continue to react until all the bicarbonate's gone and we're underneath acidic conditions. So now if I take my strips and I test, for this solution I get a nice 3-4 range, and when I look at the HCl solution, still pretty acidic, or still pretty basic. And you can be pretty generous with this HCl. So add it, now we're down to pH of 1. And so you can see no precipitate formed with solution B. So was there supposed to be a precipitate with solution B? Actually not. This compound doesn't contain any. So with B we don't expect to see a precipitate, and that's exactly what we get. But when we look at solution A here, that's exactly what we see. That's what this foam is our precipitate coming out of solution. So back it out for a little bit. So these are solution A definitely contains some precipitate, solution B did not. So we're going to take solution C here that I kind of got tucked off to the side, and we're going to run this in the rotovap, and we're going to see what comes out with the rotovap. Alright, so now we're ready to use vacuum filtration. So to do vacuum filtration, what we're going to do, we're going to turn the water aspirator on full power. Now we use water aspiration, it's a nice cheap source of vacuum for us. There are better ways of doing it, but you know, can't beat water, right? So we're going to take our filter paper, this has been pre-weighed, and I'm going to add some deionized water to it. And make sure that we get a good seal all around. So if I look at it, I can see all the holes are plugged, and you can definitely see the water getting sucked through. And now I'm going to take my solution A, and I'm going to pour it into this flask, preferably slowly. You can kind of see I just kind of dunked it in by accident. And we can definitely use a little bit of DI water, knock loose anything that's stuck to the rim of the flask. We are going to lose a little bit, that's fine. This is just part of your error. And we're going to let this run for about 5 minutes. I'm going to stick it over here on a pre-rated watch glass. Heat it up at a low heat, like 2 to 3, and give the water time to come off of it. And then we'll weigh it and see how much we recover.